today's Energy Central webcast entitled Integrated Grid Planning, a Strategic Approach to Building Resilient and Sustainable Utility Systems. And I'd like to hand the floor over to Marc Lamoureux, Senior Project Manager, AIP Applications, IFS Copperleaf, to kick things off. Marc, welcome to the event. You have the floor.
Thank you. I think I may have just gotten an issue with my webcam, but we'll plow ahead. So it's no secret to everyone that the planning environment at integrated utilities and energy companies is already complex and only increasing in complexity with the trends that we're seeing in our environment. The many sources of data and system needs, the constraints and everything else are creating an environment where decision making is getting complex, and also the constraints around that are also increasing. You can go ahead to the next slide, Sean, please. Perfect. And so in that sense, what we're seeing is that the multiple lines of business that we're planning across the multiple planning horizons, as well as from the strategic down to the granular area of decision making, is increasing the need for new systems as well as new processes to support those decision making. And from that, the concept of integrated planning looks to pull this together and provide a way to do planning at a more efficient pace that allows you to optimize capital and resource allocation, determine interventions and solutions and their eligibility, as well as understand what action needs to happen at the isolation zone and circuit-based planning process in order to drive the maximum amount of efficiency. And in order to support that mission of understanding where and when to invest, as I mentioned, new tools and processes need to be put in place in order to be able to achieve that. And there's no better way to understand how this plays out in practice than with an actual use case and story. And at this point, I'd like to hand over to Wen and the integrated planning team at PG&E in order to walk us through how that's playing out for them today. Over to you, Wen.
Thanks, Mark. Appreciate it. Good morning, everyone. Really appreciate the 150 and counting attendees that are joining this webinar. I really appreciate you guys' presence here. Really excited to share our story here at Pacific Gas and Electric. Before I do, just a little bit about the utility. So PG&E, we serve most of Northern California. We serve about 16 million people. That encompasses about 5.5 million electric accounts and 4.5 million gas accounts within our territory, which encompasses about 70,000 square miles. Within it, on our electric system, we have about 125,000 circuit miles of electric distribution. Actually, electric lines, transmission about 20,000, distribution about 108. And then for natural gas, we have about 50,000 miles of pipelines altogether. And so a very large system across a pretty large territory. And I just want to introduce myself as well. My name is Wen, and I am the Senior Director of Integrated Grid Planning here at PG&E. And so a little bit about background and why we went with deploying integrated grid planning. In California, we are experiencing a once-in-a-life opportunity in terms of growth in the electric grid. That's driven mostly by electrification, automation, and also the emergence of artificial intelligence. And the system needs the investments that we need to make into the system is multidimensional. It's driven by wildfire, by capacity, load growth. We have asset health needs as well as traditional reliability, and also the emerging climate risk as well. And so when we aggregate all of our system needs, we've come to realize over the last couple of years that we don't necessarily have enough dollars to address all the needs all at once. And so we do need to be thoughtful about investments and making sure that we're investing in our system in an efficient manner as well. At the same time, our regulators want the same thing. Our regulators want clarity, consistency, and transparency in how we invest in the grid for our customers, mostly through our rate cases. And all these investments we want to make in the system, we have to ensure that we keep customer affordability still in mind. And so all of this is to say that we really internally at Pacific Gas and Electric really had to think about how to evolve our approach for grid planning to really maximize efficiency to address the multi-dimensional complex needs of our system. And so over the last 3 years, we have built and deployed an integrated grid planning process and a technical solution that enables it. What we've done is we've aggregated 60 to 80 data sources from 20 different data sources into our homegrown Palantir Foundry platform, which we call System Needs Assessment Platform. And what it is really a tool to help us aggregate and visualize all of our asset risk and system needs. We take all that information, we normalize it so that we can compare reliability risk with wildfire risk and asset health risk, and so that we make sure that we have an even playing field. And we send all of that risk information and system needs information into Copperleaf. Within Copperleaf, we start to create those investments, identify where the system needs are, create those investments, and then ultimately we utilize Copperleaf to optimize our portfolio so that we can spit out a 10-year plan. And we're going to demo this in a second here. We're going to, my colleagues, James is going to demo the System Needs Assessment Platform, and then also Jocelyn is going to show you guys what we built in Copperleaf. Before I do so, I just wanted to speak a little bit about why we did this as well. And so in contrast to our traditional way for investment planning. So historically, what we've done is we would have various programs, the reliability program, the capacity program, come in every single year doing our annual investment planning process and really compete for the same dollars, right? The reliability program, I say, hey, give us $500 million and we can buy down this much risk. While the capacity program says, we need this much money to address the capacity growth that our customers see, and they're really competing for the same dollars. And so really the difference for us when we deployed integrated grid planning is instead of going with programmatic investment planning, we're doing a bottoms-up approach, right? So we can actually calculate the system needs down to the individual assets, the individual poles, individual conductors, individual substations, transformers, and really do a bottoms-up approach in terms of where the investment should go. And secondly, our planning now is not necessarily programmatic. It's we're shifting to a circuit-based plan. And so rather than having programs compete for the same dollars and potentially have each of the programs hit the same customers multiple times in terms of doing planned work and having planned outages, what we want to do is have all the work addressed once with one project that impacts the customer only one time, right? And so there's benefits from an efficiency standpoint as well as a customer impact. And I'll cover that after the demo as well. So that's why we did it. We're really excited to show you the demos, and I'll have my colleagues take over from here. So I'll hand over to James.
Alrighty, hi everybody. I'm James Hansel. I'm the tech lead for what we're calling the System Needs Assessment Platform, or SNAP. SNAP provides a consolidated view of asset risk on a common framework, and that is what's presented for ingestion into Copperleaf. The currently modeled risks are reliability, capacity, wildfire, financial, and public safety, but the numbers shown here are not representative of our actual data. These risks are calibrated to enterprise level risk assessments. So for example, for all these different asset types for a particular one, distribution overhead conductor, we have an enterprise level risk assessment of about $3 billion in this example. And this ensures that the individual asset risks all sum up to that total amount of wildfire risk for that particular asset to make sure that the risks getting sent over to Copperleaf on the individual assets are aligned with our enterprise expectations. Coordinating across different types of risks enables a shift, as Wen said, from conventional to integrated planning. You might have a particular asset that is high on the reliability risk scale, but if a second asset is actually lower in reliability, but higher across the total amount of different types of risk, then that latter asset is going to be the one that you're more interested in resolving or reducing the risk on first. For this, risk is calculated across 3 domains, currently just electric, but we have the substations here in these little triangles are each substations. The lines here are our transmission lines, and then these bounding polygons are the boundaries of all of our distribution circuits. and we can drill down from a territory-wide risk view down to an individual asset risk. So we can switch over here to an asset view. I don't know if the numbers are big enough here, but you can see that we have a total of, in the platform right now, 4.5 million assets. And this is just a big old listing of all those assets from highest total risk to the lowest. And having this kind of zoom from an enterprise level dashboard has executive summary down to individual assets, so that the numbers that our executives are looking at for a risk perspective match with the sum of all the individual asset level risks that our individual planners and engineers are looking at. Let's drill down further. I can zoom into, say, the San Jose division where I'm from, throw on some filters, and see that the total map will reduce down from about 4.5 million assets to the 200,000 that are within our San Jose division. And let's say I'm a reliability engineer, so I might want to filter over to start with to look at some the higher reliability risk circuits. Zooming in, the colors are all kind of based on the total amount of risk. And so we could pick a particular circuit here and switch over to the detailed assets on that circuit. You can see now that there's just about 1,000 total assets that we're looking at for a particular circuit. Drilling in a little bit further, we can see the individual, what we call dynamic protection zones, that the level that we do our investment planning at right now, which is along this circuit. It's divided by reclosers or interrupters. And you can see the kind of total amount of risk on a combined level in each of those zones. And similarly, you can flip back over to the summary of risk within this circuit, and we can see this particular circuit's an example where we have multiple types of risk. Blue here would be the reliability risk, and yellow being what we call capacity risk. It's in the future load forecasts. If we see more load on the circuit than our devices are able to handle, there could be a chance for outage or chance for unserved load, and that's where that number is coming from. But this is just to say that there are multiple different types of need on this circuit. And if we wanted to drill down kind of even further, we can zoom into the kind of individual conductors that we are showing here. And again, the closer to red colors are higher risk, the closer to yellow colors are lower risk. And finally, we can dig into kind of an individual piece of conductor. And here we want to ensure that the kind of granular asset risks are matching our engineers' expectations, so that what gets sent over to Copperleaf is actually representative of what our engineers think the risk is on our system. And finally, you can zoom into this one last little piece of conductor and see a quick summary of the underlying data that is driving these asset risk models. This is the very kind of granular view for a particular engineer, but you can zoom in from this level or zoom out from this level all the way back up to that enterprise level risk to make sure that the totals are making sense for both the kind of individual engineers as well as the top-down system level perspective. And the hope here is that we're able to facilitate a shift away from kind of a bunch of offline spreadsheets used for planning to an automated kind of standardized and centralized platform for assessing risk. And that's a work in progress, but the large majority of our data is now automated and will show up kind of with a live refresh as needed through this platform. And with that, I will pass this off over to my colleague, Jocelyn.
Thank you, James. I am Jocelyn Wong, I'm Senior Manager for Electric Integrated Grid Planning, responsible for the implementation and execution of our IGP framework as well as the resulting portfolio. As James mentioned, we are really using our SNAP product to understand the system needs, and then once you understand the system needs, that allows us to mitigate more risk per dollar spent and save costs through better risk identification, project bundling, and optimization across programs. What you see here is all of the asset data that is sent from SNAP into Copperleaf. I'm not going to dwell too far into here, but once we have the system needs identified by the asset management eligibility criteria, We can automatically create over 17,000 bundled investments. This is across distribution and transmission at the circuit and substation level that actually bundles the work together. So the example is the reliability and capacity work in one bundle together. I'm going to show a specific example. This correlates back to the example that James shared in SNAP. This is one of our circuits in the San Jose area, our Edenvale 2109 circuit. This specific investment is at a dynamic protection zone, which are the zones that we have set up. Just to give you a sense of scale, this particular dynamic protective zone is about 15 miles long, has about 150 poles. But based off the eligibility criteria, this particular investment is going to address about half of that 15 miles, so about 8 miles of this circuit segment and about 5 poles based off of the need that we're seeing for a total cost of about $17 million-ish. What I do want to point to is the value framework that we have set up. James talked about the 5 asset level value models that we have: capacity, reliability, wildfire, public safety, and financial. This allows us to quantify those asset risks as well as the benefits that doing the the benefits of the investment itself, the actual interventions that we're going to apply on a common economic scale. So I'll point you to this bottom right corner. This is a summary of the overall investment values that this investment will give us. So you can see, and these are net present value amounts. The total investment cost from net present value is about $15 million, but by completing the mitigations that would be applying as part of this investment, we would actually get $30 million of risk, mitigated risk value. And so overall, we would get a total positive investment value of $15 million, meaning you're going to get more benefits by doing this investment than the cost for the actual investment itself. So we do generally want to look for positive value investments across the board. Apologies. So we have the ability to look at all the investments, those 17,000 investments in this same common economic scale. As Wen mentioned earlier, the current investment planning process often creates competition between the different programs, such as reliability or capacity initiatives, for the same resources, whether it be financial, manpower, or materials. Under the current process, investment planning process, this one investment would have been treated as 9 different projects or programs. As you can see, actually 10. So potentially 10 different projects, 10 different timelines, 10 different competing sort of priorities, and really looking for the same resource in a timing perspective. And so by doing that, by bundling the work together, we're actually able to gain some efficiencies as well as minimizing impacts to our customers. And how this shifts the conversation is now, rather than what I would lovingly call the cage matches in the past, where everyone is arguing why their specific project or program is the most critical and important, has to be done now. Now it becomes more of a trade-off discussion based on outcomes. And that's where it will lead to how we think about scenarios. So by leveraging Copperleaf's optimization capabilities, we can ensure that our investments are executed in a manner that maximizes value in terms of risk reduction for the dollars spent. This approach allows us to create scenarios optimized against various constraints, such as objectives, meaning the amount of risk mitigation or residual risk, system risk that we are willing to accept, or resources such as financial, manpower, material, units. But by creating those scenarios, we actually can provide a clear understanding of the long-term outcomes. What I mean by that is this specific example I'm showing right now is a scenario that is constrained purely from a dollars perspective. We know how much dollars we have to spend on an annual basis, allowing Copperleaf to help select the highest value work given those constraints. And with that, we can see how our risk profile and the journey of that risk profile looks over time. So in this particular case, I'm showing what our system our residual reliability risk is on our system. You can see even though by spending some money in investments, the risk does continue to grow over time compared to something like our capacity risk, where because we are addressing capacity, that while it grows for a little bit, the risk does sort of level out over time. In addition to running individual scenarios, we actually have the ability to run multiple scenarios, which really allows our leaders to understand those tenure outcomes, the results of the tenure outcomes based off their current day decisions. In this particular case, showing two different scenarios, they have the same financial envelope, same financial envelope from a constraint perspective, but the second scenario, the yellow scenario, has additional constraints applied to that, specifically from a resource perspective. This ties to the amount of units that we can complete on an annual basis for different types of work. This specific example is the number of substation transformers we can place on an annual basis, as well as overhead conductor and wood poles, as well as underground cable that we want to do on an annual perspective. But these two different scenarios, we can actually see the same types of views from reliability risk perspective. You can see that by doing the unit constraints, we can actually potentially get more reliability risk achieved over time, or you can compare something like capacity, where you can we actually get a little bit less capacity. Remember, this is the residual risk on the system, but we can actually, so we can get a little bit more reliability, but a little bit less capacity. But by being able to compare these scenarios, and it's not just the two, there could be more as well, really being able to understand the decisions that we're making, how that could impact our system over time. So as a result, we can translate these investment scenarios to actualized work efficiency benefits, ensuring that our resources are utilized in the most efficient manner to achieve our strategic goals. With that, I'll hand it back to Wen to share the benefits that PG&E has actually realized from a smaller scale manual planning effort that we did in our distribution.
Jocelyn, could I bother you with a couple questions that have come in through the system from the audience?
Yes, yes.
Perfect. So the first one that we got was about how you conceptually differentiate between risks and how you think about the priority of the different risks that are being tracked in the system. I think you answered a little bit of that, but go into a bit more of the thought process there.
Yeah, thanks, Mark, and thanks, audience, for asking those questions. Yeah, keep firing away on them, and we'll try to hit most of them. Hey, Sean, if you can go back to the last slide, we'll just leave that slide up while we get these questions answered. In terms of risk prioritization, the really nice thing that we've tried to develop here at PG&E is a enterprise bow tie, and so at an enterprise level, we've made an assessment on equal risk terms, what we call CBA, cost benefit analysis, the various risks. So we don't necessarily have to prioritize it. It's aggregated and prioritized already through the enterprise bow tie. All we have to do here from a bottoms-up approach is normalize all the risk calculations from the various risk models to those enterprise system view outcomes in terms of risk, and we get essentially an inherent prioritization based on that, if that makes sense. And happy to discuss it more if offline if needed. Han or James, anything else you guys want to add to that in terms of how we think about risk and risk cascading risk down to the circuits?
Just to say that we ingest a good number kind of existing PG&E, either ML driven or heuristic driven asset failure and consequence models. Some of them we have a kind of very mature model. Some of them we have to do something a little bit more based on the asset characteristics like age or type, based on what our SMEs said. But in either case, that kind of driver is what's used to spread the total enterprise risk bow tie amount of risk out to those individual assets. So that matches kind of the individual asset ranking that our SMEs are expecting, and then also sums up to that total value.
Yeah, Thanks, James. And keep in mind, team, as you saw those numbers, those risk numbers that James showed in the demo, those are not our production system numbers. Those are more just for this demo. So take those with a grain of salt. Mark, any other questions that you want to see up?
Yeah, there's a question, might be a simple answer. In terms of looking at protection zones, is everything just replaced within the protection zone, or I believe the example that Jocelyn showed sort of indicated is a bit more discrete than that, but that was a question that came through.
Yeah, so at PG&E, we're trying to plan work in the bite-sized chunks, and for the distribution system, the dynamic protection zones is how we plan work. But not everything within the protection zone gets replaced or repaired, right? It's really based on the individual asset need. Jocelyn, you want to speak more to that?
Yes, correct. Yeah, so on the distribution side, we are currently creating bundles at the dynamic protected zone level. As Wen mentioned, the initial alternative is just to address those assets that are eligible coming from SNAP. But we do have other alternatives that also consider, should we be replacing everything within that protective zone? And then we'll allow the optimization tool to really select what would make the most sense from a value perspective. So in some cases, it could be everything, but in general, we are going to be targeting only those assets that have need.
Awesome. Yeah, we can continue with the content and then turn back to some questions towards the end when we have some time. If you want to keep going with the content.
Yeah, sounds good. And thanks, team, for those questions as well. John, can you go back to the last slide, please? Yeah, that one. Yep. So I just wanted to kind of put a pin on the demo here. I really love that demo. It shows really the power of having all of our risk models aggregated and having Copperleaf as a tool that really enables some automation in terms of how we think about investments and how we optimize our portfolio. But imagine this, right? So imagine if your asset strategy engineers at your utilities have a tool like Snap, where they have all the various dimensions of asset risk at their fingertips, aggregated for the entire system. The amount of decisions that can be expedited on an annual basis, it's extremely powerful tool, and we're really proud of our internal team, our asset knowledge management team, and James, who's built this tool for us. For our investment planning organization, moving away from programmatic, more qualitative valuing of programs, and moving to really a fact-based, bottoms-up approach to investment decisions, and having actual real net present value numbers in terms of whether we want to invest in project A or B or C. It really removed the subjectivity in investment planning decision making that we make every single year. And so we're really excited to deploy this tool for our investment planning partners, and really leveraging more of a objective type of process for investment decisions. So extremely powerful tool that's really functionally enabled by Copperleaf. And I did also want to highlight something that Jocelyn said. Copperleaf allows us to run multiple scenarios where our executive leaders can actually see the 10-year outcome implications for the decisions they make today. And there's a lot of decisions that needs to be made every single day based on what our customers need, right? And so when we have customer A that wants to improve reliability for their circuits, or customer B in another city may want us to invest in a new substation for a new data center that's being built. For our leaders, sometimes it's really hard to decide which commitments they should be making to our customers and at what time. And so now they have a tool where they can come back and say, what if we constrained? What if we had to deliver this project for capacity on this date? What are the implications to reliability or wildfire risk buy down for the next 10 years for the organization? And we can run those scenarios. Josh can run those scenarios and really articulate in real numbers in terms of net present value and in terms of risk buy down. What is the 10-year outcome? The power that Copperleaf gives us in terms of scenarios and modeling out the 10-year outcomes is extremely powerful, and it's something that our executives have been really excited about, and we're excited about as well. So I just wanted to make sure to highlight those opportunities in terms of what these solutions functionally enable for us. Sean, next slide, please. And so now I'm just going to talk a little bit about what the benefits have been, what we've realized as benefits. And so this circuit-based planning process, circuit-based investment planning, we piloted this process. Now all of these investments were created manually, but we piloted with a $100 million portfolio in 2024, so last year. We didn't use Copperleaf at that point to identify these bundles of work, these circuit bundles of work. We actually did it manually. We call them mega bundles. For 3 programs, we were able to achieve here on the left side. You can see we were able to achieve a 67% reduction in planned outages for that $100 million portfolio. As compared to the traditional way that we did work, right? So rather than hitting the customer multiple times, we were able to do all the work on the same circuit, on the same planned outage, and reduce outage by 67%. That translates into, you can see it down there, 4.6 million customer minutes interruption avoided. 4.6 million for a $100 million portfolio. Now we're talking about at PG&E investing $8 to $10 billion of capital a year in our electrical system. Think about extrapolating those numbers, the actual true customer impact that we can really build. And so really, really positive benefits for our customers. Not only that, internally here on the right-hand side, you can see we were able to get a lot of unit cost efficiencies for the work executed from a bundle perspective. And so for that $100 million, we were able to save $18 million for the same units of work performed as compared to our baseline. And we're able to take that $18 million and reinvest it right back into our system to address other needs. So when we talk about efficiency, this is year 1, and we're realizing 20% efficiency. The opportunities are dramatic. And so when we look at the fact that we have so many different investments that we need to make, $10 billion in investments, and even more so across the various functional areas like power generation and also gas, we've identified conservatively that we have an opportunity if we do circuit-based or pipeline-based and really bundled execution of work, $3.7 billion we can save over the next 6 years. And we can take those billions of dollars and reinvest it right back into our system for our customers. So the opportunities here are huge. So I really want to highlight that as an opportunity. It's something that we're really excited about. We're going to be fully deploying this process to about $5 billion of work next year in our investment planning process, and so really excited to see the positive outcomes coming out of that deployment. But with that, we've shown the audience here what it is that we're doing at PG&E and the tools that we use that functionally enable that process. There is also a call to action here, and because what we, when I talked about this ahead of time. When I talked about the drivers for why we did this, we talked about what the regulators are looking for from us and what our customers are expecting from us. One of the challenges that we see is that if all the utilities within our industry go into having different ways of evaluating work and in different ways of justifying what investments we want to make through our rate cases, there's going to be some, it's going to cause confusion with our regulators. They're going to be asking us, hey, why does utility A value system hardening this way while utility B value system hardening a different way? It would really benefit us and also the regulators and also our customers if we're able to build some industry consensus in terms of the value models that we utilize for this type of integrated planning process, and to provide some consistency and transparency in how the industry values the work. And so I'm going to have my colleague Sean here talk a little bit more about this consortium that we're trying to build, and that's already underway. And the call to action is for you and your team to consider being part of it. We would love for all the experts in the industry to help us build some industry consistency and drive to better regulatory filing outcomes and more transparency and efficiency for what we do for customers. Sean?
Thanks, Wen. Hey everybody, my name is Sean Ness. I'm a principal on the integrated grid planning team. And like Wen indicated, we're working on 10-year capital ideas on where we should be spending our money. In line with that, we have our own 10-year plan within the integrated grid planning team. And understanding that we're not the only utility dealing with the same issues, we really feel that it's beneficial to us to learn from a lot of the other IOUs. So we've been doing a lot of effort over the past few months of reaching out to various IOUs, identifying people that are peers of ours that are doing the same thing. And it really came to a head this month. We met a bunch of people in Nashville at IFS Connect a couple of weeks ago, and identified a number of other IOUs that are would like to join with us in this process. We're here today to announce it in a more public fashion. In 2 weeks, we're going to be convening with some of our peers in Southern California with SCE, SoCal Gas, San Diego Gas Electric, and doing a really rugged benchmarking session. Where we'd like to come out of that is with a strong understanding of where we have gaps in risk models and value frameworks. What do we need to learn and uncover over the next few years? In July, we're going to have a public announcement around industry consensus white paper creation. So we'll have a task force that's created to identify participants for an initial white paper. And in this fall, we anticipate hosting an event where we staff the very first white paper. By next year, we expect 1 white paper to be published, and by the following year, 3 white papers to be published. So we have a couple of years of interesting activities ahead of us. Those white papers will be used to align all the stakeholders within our organization, within our peer IOUs, as well as with the regulatory and other interested parties that would like to know about what we're doing. So a lot of effort around education and advocacy, and eventually the real holy grail is to improve the regulatory filing process. With that said, we'd like to move over to Q&A. We know that some people might need to drop off, so please grab a snapshot of these email addresses and names so that if you do have questions that you think about later, feel free to reach out to us. But right now I'm going to hand it over to Mark to facilitate any ongoing questions as we round out this webinar.
Brilliant. Thank you, Sean. And so, yeah, we've got a number of questions coming in, a variety of topics. I'll consolidate a couple things here to get us kicked off. So the first area that folks had some questions around was the use of Copperleaf and the footprint. And could you comment a bit, or someone comment on the footprint today and your thinking moving forward? And also there's a question on the change management aspect, as well as the timeline. I think Wen initially had mentioned 3 years, but again, sort of the footprint, sort of 3-parter, the footprint around Copperleaf, the timeline, and then also how you thought about the change management aspect as you've progressed.
Yeah, so really high level here. It took a lot of various efforts to get to this point. I mean, with the system needs assessment platform, that's only an aggregation visualization tool, and so the number of risk models it actually aggregates between transmission and distribution. Those models have been developed over the last 5-10 years, right? So our distribution asset risk model that was developed 5 years ago. Our transmission composite risk model was developed probably matured by about 2 years ago, and it's still continuously improving. So a lot of work has gone to this point. The assets that we are evaluating, it's not all of our assets. So we still don't have our protection assets and some of our substation assets. So right now it's really focused on wires, poles, transformers, switches, I believe, in really the big investment programs. And so as we, so right now we can optimize about 65% of the entire plannable capital investment program, asset investment programs for electric, and we're looking to bring in additional asset classes and additional investment programs then. As we move forward, but it does require additional risk models to be built to do so. Remind me, Mark, what was this other dimensions of that question?
So how you're thinking about the footprint that you have today with Copperleaf and how that's moving forward. There's some questions on specific modules and things like that, but just generally around the use case there. Yeah, so kind of footprint, I can take that question 2 different ways. So footprint can talk about what from the optimization and circuit-based planning process that we use Copperleaf for. What is encompassed? Again, 65% right now of our entire capital portfolio, so about $5 billion a year, and we're trying to move to 100% over the next couple of years, and also trying to inform expense work as well. So bundle the expense work
the maintenance work with the with the capital work as well. I can interpolate footprint also meaning what modules do we use in Copperleaf. In that sense, we are using Copperleaf assets at this point, and a Copperleaf portfolio, obviously. But we are doing a lot of calculations in our system needs assessment platform in Snap that predictive analytics within assets in Copperleaf that can also be done. The reason we did that is because we want to have a little bit more control the first couple of years in terms of making adjustments quickly, being a little bit more nimble. We also have a automated investment creation tool that Copperleaf helped us build. We're utilizing that to automate the investment creations right now. And there probably will always be a place for some efficiency for automated investment creation, but we're also evaluating how we can provide more flexibility for our planning engineers by allowing them to create investments manually, utilizing kind of Copperleaf out-of-the-box tools as well. Jocelyn, James, anything else you wanted to say about that question?
No, I think there was a subpart regarding change management. Mark, I think that was originally part of the question too. It has been a journey for us here at PG&E from a change management perspective of really making sure that our stakeholders across the board, because we impact stakeholders all the way from the upfront planning all the way down to our execution operations partners. That journey has it's been a little bumpy, but partly because we're really learning both the product as well as the process as we grow, as we're getting the stakeholder engagement and involvement in the process development, as well as like really understanding these tools and products that we're developing. It'll be a continual journey down this path, but we are continuing down our management of change to really make sure that the process that we're really looking to build from an integrated planning perspective gets embedded within the company.
Yeah, Jocelyn, that's a great point. I just add on to that. With this integrated planning process, we've made two really fundamental changes. We're doing a bottoms-up approach for investment evaluation. That hasn't been done before. It takes a lot of data to drive that, by the way. But the second is now when we talk about execution in investment planning, we're talking about circuit-based rather than programmatic. And the entire organization at PG&E is right now structured program by program. There's various PMOs that deliver on various programs. And now all of a sudden we're trying to bundle everything to be circuit-based. And so really thinking about it as a regional model. The organizational change that's required to handle that is pretty big. And I would recommend that anyone that's thinking about doing circuit-based planning to be really thoughtful about the organization that's needed to support that type of planning and execution. Mark, any other questions?
Yes, there's no shortage of questions. The next set is around the regulatory aspect and how the impacts of the bundling approach and this process has had on GRC, as well as the impact in regulatory filings of any benefits realized by the bundling, and also whether there's been internal benefits as well around streamlining the regulatory process and defining of asset strategies.
Yeah, so really good question. It's something that we really believe here at PG&E that this integrated planning approach is going to simplify and make our rate cases more transparent. But we're not quite ready to fully incorporate integrated grid planning process and take what comes out of Copperleaf and put it directly into the GRC. There's a lot of massaging of the data and making sure that where we have a good justifications for what goes into a rate case. And so that's why we have the 10-year plan. Our intent is to fully mature the integrated grid planning process over the next couple of years. And so that in the next iteration of our GRC, that we're able to really leverage what comes out of Copperleaf and feed it nearly directly into our rate case. But what we did do for this rate case, we just actually filed our 27 to 31 30 rate case, and we put a couple paragraphs in there to kind of introduce the concept of integrated grid planning to the regulators and to the third-party interveners, and expecting more conversations and more interest coming in. And so we're looking for a ramp up to really get really mature before we fully utilize it for rate case. That's where also what Sean was talking about in terms of the consortium. You know, we understand and recognize that that we probably need a little bit of industry consensus on some of the value models so that there isn't confusion from our regulators, you know, at all the states levels on you know the evaluation and the benefits that we're claiming for various types of work that we're doing for various drivers.
This one relates more to the bundles themselves, so more of a practical question as to where the bundling occurs, and is it currently rules-based, and how do you think about adjustments to those bundles?
Yeah, so I'll let Jocelyn weigh in on this as well, but just so right now we have an automated investment creation tool that does the bundling itself, and the bundling rules are pretty basic, right? We're just looking to consolidate all the work for a dynamic protection zone or a circuit or a substation. So the bundling rules are not very intelligent at this point. We are this year taking one pilot project and a bunch of dummy projects from Copperleaf that have been bundled together, and we want to do a tabletop exercise with our execution teams to figure out which bundles can actually be executed and what bundles need to be broken apart into maybe 3 different bundles, as an example. For example, like, you know, a bundle project for the poles and wires, but maybe a different bundle for the protection device, you know, things like that, depending on what type of expertise is needed to execute in the field, and get more intelligent rules and feedback from our execution team so that we can incorporate those into a more intelligent bundling mechanism within Copperleaf, or do it manually. And so we're still learning on that, and trying to get feedback. So if there's any industry learnings, we'd love to benchmark with other folks to get ahead of maybe some execution challenges we might face later on. Jocelyn, anything to add?
Yeah, I would just note that what we're doing within Copperleaf and that investment creation tool is just the initial scope for what we think the investment would be. We do recognize it will go through detailed design and engineering and execution, and so we do expect to continue to update those bundles throughout the life cycle of that investment, as well as feeding that intelligence back into our logic. As Wen mentioned, we're taking a very simplistic approach right now with the sort of concept of investment zones, for distribution being the dynamic protective zone, but we are going to learn, and we're going to continue to basically improve that logic as we grow, as well as getting the feedback from our operations and execution partners.
I do see a couple of questions around risk models that I just want to address, Mark, if that's okay. So there's some questions about differentiating distribution versus transmission risk models, and there's some questions about how, you know, I interpret it as like transmission reliability and potential capacity issues, like rare events and things like that. So yeah, those are problems that we haven't solved necessarily yet. We do have different models, asset risk models and reliability consequence, wildfire consequence models for transmission and distribution. So those are kept separate. On the transmission, we are still struggling to develop what we consider a comprehensive model for both reliability and capacity. So on the reliability side, yeah. So on the distribution side, you know, we use the ICE calculator. It's fairly, you know, fairly consistent within the industry how reliability is valued. On the transmission side, you know, reliability is it availability? Is it really resilience to catastrophic events? And so, you know, do we need to do Monte Carlo simulations to understand the N-2, N-3 types of events that could happen? We're right now in the very beginning of some internal thought leadership in terms of what approach we're going to take, and who's going to build those models for us. So love to have a conversation around that with the industry. Mark, back to you.
So that covered some of the questions relating to the risk. Moving over to we also talked. So how do you take capacity, loading, and projects into consideration? That seems somewhat close to what you just articulated.
Yeah. So if we didn't have constraints in terms of capital dollars we have, capacity projects would be deterministic, right? We do our system planning every single year on the distribution transmission side. We identify where we anticipate load growth, and we address it by a certain date, whether it's a commitment to a customer or to CAISO. It's generally relatively deterministic. But as I alluded to in the beginning, we have multi-dimensional needs right now and a limited amount of capital. And so we really need to do it from a risk-based standpoint. And so that's why we need to develop a capacity risk model. I don't know what that looks like right now. That's the challenge. And so we're having some internal discussions about what that would look like and how we would prioritize the capacity work. But typically there's external commitments. And so we may end up leveraging some timing aspects of timing constraints within Copperleaf to help anchor capacity projects as part of the optimization. So that we might address it that way, but more to come on that.
What I would say, we do take some loading forecasts into consideration when we think about eligibility. So meaning we are trying to build some margin from a capacity standpoint where possible, meaning as examples, if we're going to be replacing a conductor for life cycle purposes, let's make sure it's sized appropriately for the known load forecast in the area, right? So we are trying to take where we can at least the data into consideration in SNAP, so we can at least see where there may be future loading concerns.
Speaking of SNAP,
Miriam, is there anything else that you guys would want to mention about like our thoughts around reliability and capacity models on the transmission side? Anything else you guys would want to mention?
Yeah, just like so this is Hong Chen, IGP principal engineer. So I think just like what Jocelyn mentioned, right? Today we do getting the load forecast data, 10 years load forecasting data from our distribution planning team, right? And we do using the load forecasting data to help us to to figure out the capacity risk for our investment also. So we do consider, so today our capacity value model, we do using the forecasting data to figure out the likelihood component of our capacity value model. Yeah, for distribution. That's the thing that I would like to add. Yeah.
Thanks, Hon. Mark, back to you.
So we got a couple questions around data quality and how the data gets combined, the inputs into SNAP. So some questions around that process and how you're thinking about perhaps overly generalizing, or the risk of overly generalizing data in terms of its quality.
Yeah, like our friends at TVA, Mark from TVA would say, don't let data issues get in the way of actually utilizing the tool, right? Everybody has bad data, but it is what it is, and it's the best that you have. And so making a decision with it is something that's just be cognizant, but to utilize it as is. James, maybe you can talk to some of the data issues that you guys have encountered and how you guys have tried to mitigate those data risks within SNAP.
Sure. It is an upstream platform, but I'd say in that Foundry platform, a large majority and a growing majority of the data that feeds into SNAP and then into Copperleaf is based off of data sets that have kind of maturity requirements within PG&E and stakeholders and IT teams that are in charge of maintaining an existing pipeline and data quality checks and assurances that things are kind of fresh and up to date. There's still a little bit that's coming off of more detailed engineering analyses or softwares that are coming kind of from a spreadsheet and getting put into this process, but a lot of it is based off of these foundational PG&E data sets that have a bunch of kind of data quality structure around them upstream of SNAP and Copperleaf that we're able to leverage to ensure that the quality of the data going into Copperleaf is high.
Yeah, and I'll also mention that, so James comes from our asset knowledge management, our AKM organization, led by Jay Singh, and Jay and team have developed an asset data reconciliation process where they are addressing a lot of data issues on an annual basis as issues are identified, and this is obviously a continuous effort. And so I believe they were able to reconcile something like 50,000 data issues over the last year. Within that process, and so that is something that we're cognizant of. It's a continuous improvement process, but we're not letting that get in the way and we're not getting into analysis paralysis, and we're utilizing what we have, the best that we have, to make decisions today.
Perfect. So we have two, I think, somewhat related questions. One is around why the value framework has both positive and negative numbers. I guess I can take that one. It's to quantify the fact that you have costs that come in as negative, and you also have benefits that are positives. You also have additional risks to execution of work that can come in as negatives. So it depends on how you want to do the valuation, but there are both, it's almost like looking at pros and cons in certain cases, where you have pros of doing work, cons, and then other risks that come in as negatives to those positive benefits. And that's why the framework can accommodate both those, and it's got flexibility to do that. The second part of that question is, in terms of the system that's been presented, does more risk get added to the system with new investments? And the example being given is that a new feeder that shovels a forest would only add risk. Another one, a different alternative, could be that you have some sort of spare, and so the first option could add a different type of risk into the system while mitigating something else. Speak a bit about, I guess, the trade-offs implicit in some of the alternatives and the different interventions and the solutions that are possible.
Yeah, so we do a life cycle risk analysis and life cycle costs analysis based on risk for various mitigation for various alternative mitigation. So, for example, to address wildfire risk, we can do a lot of different things. So options, for example, we can do overhead system hardening. If we do that, we're installing cover conductors, but we still have to do the vegetation management, right? So that's still for us, excuse me, a $1.2 billion expense cost per year. We can also do undergrounding, but that right now costs about $3 million per mile, and so very, very expensive to do upfront. But you save on the expense costs through the entire rest of the asset life cycle. And that's something that we've been trying to argue and educate with both our customers and regulators. Or we can actually retire the line and do a remote grid as well to provide electricity to, if the customers at the end of the circuits are, they have relatively low load demands. And so we do address those. We do analyze the various alternatives that's not automated within the system, and try to decide on the best approach. Jocelyn, anything you want to say about what Copperleaf can do for us on that?
I don't, but I would say what was brought up is a good point, though, right? There are some situations or alternatives that we would be applying that could actually create more risk in other areas, and so I would encourage this audience, if you guys have suggestions of how we should be doing this, please join our consortium to help us really think through the logic here and what the value models should look like in this space to be able to capture things like that, where now the line was going through one area and now we're putting it through a forest. How does that change the risk? How do we actually capture that change, the overall risk overall? And it may be a negative value, as Mark mentioned. Right now you're talking about a potential risk that we're adding to the system versus actually mitigating.
And so if I know we have some questions that we didn't have time to get to, we do have the emails on screen for folks, so please feel free to reach out with additional questions. At this point in time, given we're right up against our timing, I'd like to pass it back to PJ to finish us off.
Thank you, Mark, and thanks, panel. Fantastic conversation today. For our audience, we hope you've enjoyed today's discussion. As you log off, please take a moment to complete our survey and give us your feedback so we can continue to provide you with quality content. Thank you for attending, and this does conclude today's presentation.